So good evening. Myself, Dr. Supreetha, Professor at Department of Electronics and Communication Engineering, MIT Manipal. Today, I would like to present my research paper on rainfall prediction model using support vector regression in Udupi region, Karnataka, India. So the flow of my presentation goes like this. Introduction, research objectives, description of the research work, results, followed by answers to the review comments. To introduce the topic, basically in this research work, we have developed a rainfall prediction model using support vector regression in Udupi region, Karnataka, India. So we have selected Udupi region as a study area because by considering the groundwater resource availability and utilization. So the main source of groundwater in Udupi region is rainfall. The recharge through rainfall is very important. So we observe there is a continuous variability or inconsistency in the rainfall and variability in the rainfall. So the recharge from the rainfall during the monsoon season, if we will consider, we will see some of the trends here with respect to the recharge from the rainfall or recharge from other sources. Okay, so with this, if we will see the groundwater resource assessment, the stage of groundwater level is declining year by year. So groundwater development extraction has increased in the year 2017. Because of that, we observe there is a decline in the groundwater level. So we can relate it to the groundwater level scenario in Karnataka. So we see some of the scary statistics 2007 to 2017. So specifically in Karnataka, you can see the percentage of groundwater level scenarios. So as per the reports available with the Time in Indian Express, South Indian states are in worst states as per the groundwater level is concerned. So that's what we have selected Udupi as a study area. So if we'll give the details of the study area, groundwater mainly occurs in different geological formations like lateritic, etc. And the tropical climate also here, it is average, we will say. The precipitation here is about 4,360. So, and also we have plotted the groundwater level spatial map for 2016 and 2017. Our study area is 2000 to 2017, and based on that, we have predicted for 1 year ahead and monthly prediction also. So we observe for the pre-monsoon, there is a continuous decline in the groundwater, that is because of inconsistency in the rainfall. Even for 2017 also, we have plotted the spatial groundwater level map, and we have studied a lot of research papers starting from very basic model, that is a mathematical forecasting model. So NWT models, although they are accurate, but with respect to the high performance facility with the changing environment, they are not suitable. So we have selected the data-driven models. Essentially, hydrologists mostly use modeling the rainfall runoff process using data-driven models only. In the literature, we observe a lot of work has been done with respect to feed-forward neural network as well as a feedback neural network. So even I worked with developing groundwater level forecasting model. We're using ANN as well as LSTM, recurrent neural network, but it requires larger data. So with the available data, we have selected SVR approach to develop the prediction model. So that is regarding the literature. With this literature part, the main goal is to develop a soft computing based rainfall prediction model to understand the temporal variation, and algorithm what we have selected is SVR. Main motivation, just now we have seen the groundwater resources, scenarios, and inconsistency in the rainfall. And since it is a smaller data, we have selected SVR as our tool. So coming to the overall methodology, initially we identify the area, we collect historical rainfall data. So then we develop the model based on the data. Then we will compare the linear model as well as SVR as a tuned SVR. And since it is a data specific model, we will recommend this model for smaller data sets, specifically in Udupi region. And the methodology block diagram, again, with respect to the historical rainfall data from 2000 to 2017. So we have predicted for 2018, 1 year ahead, as well as a monthly prediction also. Then This is a study area what we have selected. This is a location map of Udupi district. We can see here. So rainfall trend in this Udupi district is something like this. We observe the rainfall data variation in specifically 2015, 16 and 17. The rainfall patterns. Highest southwest monsoon rainfall in the state during the year 2019, it is 3,664. We observe there is a delay in rainfall in 2017 and 18. So we have predicted it for 2018, which is validated using the actual records also. So these results. We have time series plot, what we have got. It is again here, this is a monthly basis, this is for yearly prediction. We observe there is a decline for this particular month, 10 months or whatever. Here, yearly point of view, you observe there is a decline in the groundwater level year by year. And also the statistical results also prove that the error values shows the above statistical indices shows the global goodness fit between the computed as well as observed rainfall records. And we also plotted the RMAC for the SVR model for all the 3 months, May, September, and October, different months. With this, we conclude that the predicted rainfall records are validated with the actual records as per the Indian Meteorological Department. There was a heavy rainfall observed, terrible downpour occurred in August 12th and 15th. We predicted it for that is correlated in our graph also. The maximum rain of around 1,367 mm recorded by IMD in the month of August 2018. Therefore, it is concluded that overall rainfall in 2018 would be average and with high variation was observed in Udupi. That was also observed in our results. And to answer some of the questions posted by the editor, first thing, what is the scientific question you are addressing? The main scientific question what we are addressing is water scarcity. There is a chance of water scarcity in coming future. So due to the decline in the rainfall or inconsistency in the rainfall, that was addressed in this research paper in this particular region. And also as per the editor's advice, the background problem proposed solutions are briefly elaborated in the revised paper. And coming to the key findings that answer this question, key findings, we found that there is a strong correlation between the computed results as well as the observed results. We validated the predicted rainfall records with the actual records. So we found that there is a strong correlation and it is region specific. And next, coming to the significance, the main significance in the this thing is water resource engineering, management and planning. So this rainfall forecasting is very important because the irregular rainfall can have many impacts in the agriculture sector also. So that they can properly plan and manage the agriculture farms in the better way. That is the main significance of this. And yeah, with this, I would like to conclude my presentation. Once again, I would like to thank the chief editor of this journal for giving me an opportunity to present my research paper within 15 minutes. Thank you, sir. Thank you once again.